Hey guys, let's talk about 4-5 today. 4-5 is a special case when factoring. It's called the difference of squares. And it's kind of a little shortcut when you have, when you're trying to factor two things, when you're trying to factor two perfect squares and there's a minus sign in between them, there's a super easy shortcut that can be done. And it is the factors of the first. So A plus and minus the factors. A squared is a perfect square because A times A is A squared, and 1 is a perfect square because 1 times 1 is 1. Let's take a look at number 2. 9b squared, that's a perfect square because 3b times 3b, something times itself, gives us that 9b squared. 4 is also a perfect square because 2 times itself gives us 4. We just follow the pattern. So our first two go in our first spot. 3b, 3b. One's a plus, one's a minus. And then the factors of our second one, 2 and 2, go in the second spot in our binomial. What's the pattern? Well, the pattern, typically you see this as kind of like a formula with A and B. So A squared minus B squared. So this represents a perfect square and this represents a perfect square because A times itself is A squared and B times itself is B squared. So the factored difference of squares here is always A plus minus B. So the factors of our A is going to be the same thing if it's a perfect square, and the factors of our B is going to be the same thing if it's a perfect square. Let's take a look at a couple more examples. Factor these mentally. First, we have to make sure that they're perfect squares. X times X, well, X times itself gives us X, so that is a perfect square. And 3 times 3 gives us 9, so that's a perfect square. So here's our binomials, X plus X minus 3 and 3. That's the shortcut for difference of squares. Let's take a look at number 4. D times itself gives us D squared, and 11 times itself gives us 121. So we do have difference of squares here. So we can do our shortcut, D plus, D minus, 11, 11. So you can just keep going. Let's look at, I don't think you guys need me to beat this in the ground. It's pretty basic. Let's look at number 10 because there's a fraction in it. I know that freaks you out. But is this a difference of squares? Well, that's 1/9 c squared. We can break that into 1/3 c times 1/3 c. So 1/3 c times itself gives us 1/9 c squared. That's a perfect square. And then we know 64d squared, well, that's just 8d times 8d. So 8d times itself. So we do have difference of squares. Same process, right? My first one, 1 plus, 1/3 c minus, 8d, and 8d. Guys, if you have any questions, come pop into tutorials or shoot me an email. Bye.